Hey McRinter kids, today I'm going to show you, last video was about how to figure out what a common denominator would be, and today is once you find that common denominator, what you do with it. So let's take a couple equations. I told you in class that when you have an equation that's written side by side with it written horizontally, that I want you to rewrite it vertically. So let's do the first one. The first one I'm going to give you is 2/5 plus 1/4. And we said our three options for finding common denominators. We could multiply the two denominators together, we could run the race, or we could use one of the existing denominators if the other one went into it. 4 does not go into 5, and 5 doesn't go into 4 evenly, so we know we can't use that one. So you can either multiply them together or run the race to find the least common multiple. In this case, you would get the same number, which is 20. So when you have your new denominator, you're going to go ahead and draw your equal sign and your new fraction bar, and you're going to write your denominator for both. You could also come down here and write that as the answer. This is a useful trick to write it here because you know we're only going to add and subtract the numerators if the denominators are the same. We never touch the denominators other than finding one that matches. And then in class we talked about the do-do rule. And what that means was what you do to the bottom, you do to the top. So a lot of kids get stuck at this point. They know how to write the denominator, but then they don't know what to do. So the question I want you to ask yourself is, how do I get from my first denominator to my new denominator? And it's going to be different on the top equation and the bottom equation. So how do you get from 5 to 20? You multiply. What do you multiply by? Multiply by 4. So your do-do is what you do to the bottom, you do to the top. So if you're multiplying 5 times 4, you're going to multiply 2 times 4. 2 times 4 is 8. We'll do that same process again. It's always going to be multiplication or division, how you get from one to the other. So how do you get from 4 to 20? Multiply by 5. So you do, multiply the top number by 5. So your new fractions are 8/20ths and 5/20ths, and now you can add the two together. All you're adding are your numerators. So 8 plus 5 is 13. This is the do-do rule. And you already have some notes about this in your binder. We'll do one more, in your spiral. We'll do one more like this. We'll do a subtraction one. Let's do 4/50 minus 1/5. Actually, let's just do addition. Okay, so one of our options was to multiply the two together. 50 times 5 is going to give us a pretty big number. We could run the race, or we could use one of the two numbers if the other one goes into it. We know that 5 goes into 50, so let's just use 50. I'm not even going to change my top fraction, so this one's super easy. I'm just rewriting it so that it lines up. So now, how do you get from 5 to 50? What do you multiply by? Do? Multiply them both by 10. So we have 4/50ths plus 10/50ths equals 14/50ths. Now, this is not a simplified fraction. So I know in 4th grade you guys talked about how to simplify fractions. You figure out what you can divide them both by. And we've talked about factors, and when we did our prime number chart in our math composition book. So looking at them, I know that I can divide them both by 2. This is kind of the reverse do-do rule. What I did to the top, I did to the bottom. So 14 divided by 2 is 7. 50 divided by 2 is 25. This is my fraction in lowest form. The other thing I want to talk to you about, besides adding and subtracting fractions, is how to find equivalent fractions. A lot of times some of our basic fractions are our hardest. One of your homework assignments from this video is going to be to come to me and ask for this fraction chart. I'm going to give you this fraction chart. It's a useful tool for some people when they are trying to find equivalent fractions that are some of our benchmark fractions. Because as you can see, it starts with one whole at the top, and then it's broken into halves and thirds and fourths. And what you can do is you can follow this half line down the page and see what the equivalents are. So you can see that 1/2 is equivalent to 2/4. It's equivalent to 3/6. It's not equivalent in fifths. So one of your homework assignments is going to be to come and see me, get one of these fraction pages so that you can glue it into your math composition books. That's a pretty easy homework assignment. But I want to show you a different way to do sum addition. I'm going to take these same equations that we did on the top, and I'm going to do it a little bit easier of a method. And I just learned this method, and I thought it was super cool. I'm going to rewrite these horizontally. Okay, this is your original equation. This is going to be an easier method to get an answer, but most of the time you will have to simplify it more. And there are some specific steps. So with this easier method, there is a lot of different ways that you could mess up. So one of the things that you're going to do when you're adding and they have different denominators, the reason you'll like this method is you don't have to change the denominators. All you're going to do is you're going to multiply across. So 5 times 4 is 20. Okay? Then it's important that you're going to start left to right on this one. Last year you learned, or maybe third grade, you learned the butterfly method for how to compare fractions, and we're going to kind of use that. You're going to multiply 2 times 4, which is 8. And then over here you're going to multiply 1 times 5, which is 5. When you add those together, you get the same answer. This is a much easier way to get the answer, but there's so many other methods of adding fractions that look like this that it's a lot easier to also mess up. So this one would take a lot more practice. Let's look at this one that we did here, because it's not going to get our exact same answer, and you'll see what I'm talking about. So 4/50 plus 1/5. So our first step was going to be just to multiply across. Now you got to remember, you're only going to multiply across on the denominators. So you're going to multiply 50 times 5. That is 250. And now you're going to start left to right. You're going to start with your left numerator. You're going to multiply 4 times 5, which is 20. And then you're going to multiply 50 times 1, which is 50. If this was a subtraction equation, you would do it the exact same way, except you would just subtract in the middle. So now we're going to add them, and we have 70 over 250. You'll notice that this is different from our original answer, which was 7/25, and that's because it's not in simplest form. So if I look at this, I can see that I can divide them both by 10 by doing the do-do rule, and my answer is 7/25. So I'm going to give you a couple of homework problems I want you to try on your own. I don't care how you do it, and I don't have a fancy name for this butterfly method. I guess we can just call it the butterfly method. But I'm going to give you a couple of practice problems, and I want you to write which method you're using, and I want you to solve part of them with the do-do rule and part of them with the butterfly method. I don't care how many you do of each, but at least one of each. And I want you to write which method you've used to solve it, because I want you to practice both. That way you can determine which one you think is easier. All right, here's your first equation. You need to get something to write this down with. (13/15) plus 1/3. Your second one. 7/8 minus 2/3. Your third equation. 1/7 plus 1/2. And your fourth equation. 1/2 minus 3/16. I'm going to leave that there for a second so you have a chance to copy them all down. Now I want to show you, if you to use your fraction strips, I think one of the equations was 7/8 minus 2/3. You could come over here and you could go all the way across to 7/8. And then you could look up to the thirds and you could figure out what you're left over with if you take away 2 of the thirds. So that's how you can kind of use this fraction chart to help you. Also, I'm going to show you one more thing, because a lot of the times when we're adding or subtracting, we're going to get what we call a mixed number. A mixed number is when we have a whole number and a fraction as our answer. For example, excuse me, 1 3/5. Okay, 1 3/5 is bigger than a whole. A lot of the times your equations for addition and subtraction might say 1 3/5 plus 1 1/3. We don't set this up any differently for the do-do rule. You just have to remember to carry over that whole number. But if you're doing the butterfly method that we talked about, you have to then convert this into an improper fraction. Okay? So 5/5 is 1 whole. So we have 1 whole plus 3 additional fifths. So we have 5/5 plus 3/5. You could rewrite that as 5/5 plus 3/5. Or another trick I do is you multiply the whole number times the denominator plus the numerator. So 5 times 1 is 5 plus 3 is 8. So this is the same as 8/5. And then your denominator times your whole number. 3 times 1 is 3 plus 1 is 4. And now you can do your butterfly method. 5 times 3 is 15. 8 times 3 is 24. Plus 5 times 4 is 20. So when we add these, we have 44/15. So now this is in the form of an improper fraction, which basically means the numerator is bigger than the denominator, which means it's bigger than a whole. So you ask yourself, how many 15ths is a whole? If I have a pizza and I divide it into 15 slices and I eat the whole pizza, how many slices did I just eat? That's 15. So 15/15 is a whole. So now I have to figure out how many groups of 15 are in 44. So I can skip count by 15. 15, 30, 45. Well, that's too high. So I know I can get 2 pizzas out of this, right? 15 and 30. And so then I'm left with how many is left over at that point. So I'm going to take 44 minus 30. And 14 is what's left over. And this is in simplest form. We'll talk more about this part in class, but I wanted to introduce you to it. And as always, if you have any questions, please let me know. Thanks so much, and y'all have a great weekend.